All right, well, welcome to the session, Building Private Clouds on Windows with Windows Azure PAC. The session outside, you'll notice, said Windows Azure Services for Windows Server. That has now been rebranded and relabeled the Windows Azure PAC, or just Azure PAC for short. And that's what we're really going to talk about today is what is this thing we call the Azure PAC, and what is it for? And how does it relate to what we're doing out in the Azure world? Out of curiosity, how many people in the audience today are actually using Azure right now? Okay, a couple. Looks like about a quarter of the group. All right. So let's go ahead and get into this. One of the things that we kind of want to bring to the forefront here is that our cloud strategy is fundamentally a multi-cloud strategy. What does that mean? We certainly have the Microsoft-hosted set of services in our data center called Windows Azure that we run and provide for the world to come in and consume services in our data center. But we also recognize that there does exist real compelling business needs to deploy cloud services and infrastructure inside your own data centers as an enterprise customer to deploy and run your own private cloud on-premise and still enjoy some of the benefits and capabilities that we provide in our public cloud for you to provide in your own privately hosted cloud in your data center. We also recognize that we have a lot of hosting partners out there in the world today that run data centers, make those data centers available to their customers and other enterprise organizations. And they too would like to be able to offer these set of Azure services, these cloud capabilities to their customers that is consistent as part of the cloud OS as we think of it. So this one consistent cloud platform is what we call the cloud OS, and it's about having a consistent platform across our data center, enterprise data centers, and hosted data centers. Ultimately, this is what we think of as transformational event right now across our data centers and enabling a new set of modern applications that can scale elastically, unlocking insights and data, and empowering this people-centric IT and a self-service experience for how customers can come in and provision capacity on demand and go ahead and recycle capacity when they no longer need it. So in this release of the Windows Azure PAC, we're bringing a couple of services from Azure and making them broadly available outside the Azure data center into our partner data centers. Specifically, the first workload that we're bringing is websites. Now, you might go, wait a minute, websites? Come on. We've had websites for years. What's special about this? We've been doing websites on Windows Server since way back, running IIS. What are we talking about websites here, and why is that special? And I'll share a little bit about this. If you're running Windows Server today, the way you do web hosting is with IIS, Internet Information Server. But it's fundamentally a server-centric web deployment or a web hosting platform. And as a platform, people have started over the years trying to build out web farms and trying to deal with some scale and elasticity issues. And one of the things that the team realized very early on is that it needed to evolve to become a web or a cloud-first platform where cloud capabilities are built intrinsic into the platform. So that team, the IIS team, went back and re-envisioned what it meant to be a web hosting platform and rebuilt a new PaaS, a web hosting PaaS. It's a multi-machine PaaS with built-in load balancing, built-in scale, built-in frameworks that it supports, a ton of capabilities, a lot of DevOps scenarios, built-in source code control, elasticity for providers to grow clouds, elasticity for tenants, customers coming in to scale individual websites on demand, built-in capabilities for customers to change their own SLA for how they're consuming them websites. As a platform, as a web platform, there's a new service. We run this in Azure. It is called Azure Websites. It is a PaaS. It allows us to support hundreds of thousands of users at a much smaller cost than it would do on traditional IIS hosting. So there's a lot of advantages for an operator. I can get true high-density hosting, but also I offer my customers even more capabilities than they had before. So this is a new service. It's a service that we run in the cloud, 24/7 support. We maintain this servers. It's that technology, that stack that we're actually decoupling from Azure packaging it up in the Azure Pack for deployment in your data centers to provide that same capability to your customers. Or if you are the customer, if you're that developer, you can go to your IT department and go, oh, please deploy this for me so I can get that same Azure capabilities and have that same elasticity for my applications on our on-premise cloud. Okay, so that's what this website is about, that new website PaaS that was designed and developed for Azure, making that available on-premise. We originally released, by the way, this initiative started with the Windows Azure Services for Windows Server. It actually went out with System Center SP1 in January, and this is the second incarnation of that. And one of the new features now in the Azure Pack is Service Bus. Service Bus is a service that we run and operate in Azure. It's been on-premise for a little while, but what's changed now is it's been fully integrated with the Azure Pack to provide the same model that we provide for Service Bus on-premise as how it's operated in Azure today. So developers can have the same management experience for managing their topics and queues, which they don't have today. Service Bus today on-premise is almost like an embedded runtime. Here, we make it more of a shared service, so it can run in the Azure Pack. You get a self-service experience on it. But it was one of the top requested features for integration in the Azure Pack is you build kind of these modern cloud applications. If you're going to build an application that scales to address additional needs, often your application is more than a standalone entity. It's an application that may be communicating with other applications. It may be communicating across cloud boundaries. It may be, kind of running on a public tier and communicating with some back-end services. Those back-end services may or may not even be on Windows. They might be on other platforms. They may even be on mainframes. We've got situations like that. So you need a system that can reliably deliver messages between tiers of an application and across platforms so that you have a reliable messaging platform so that you can handle burst traffic coming in and peel it off as you have the ability on the back end to peel them off in a reliable way. And so that's one of the attributes of a modern cloud application to support these messaging patterns. Service Bus is being used for that in Azure today and is now integrated with the Azure Pack for that solution on our on-premise and hosted solutions. The next workload that we have in the Azure Pack is virtual machines. Now, this is kind of like websites in a way. You say, wait a minute, we've been doing virtual machines for a while now. System Center does virtual machines. That's there. So what's different? What about the Azure Pack changes what we mean about doing IaaS and virtual machines? For those of you that are familiar with Azure, we just GA'd, which is kind of RTM'd in the on-premise world, the IaaS experience for infrastructure as a service in our public cloud offering, so that the world can come in and basically provision production applications now on IaaS, on VMs. These are like real VMs, not kind of a PaaS-y VM role, but real VMs in Azure. They can do that today, and there's a self-service experience that goes with that. How do I provision those VMs? How do I manage the health of them? How do I monitor them as a consumer? Not as an IT operator, but as a consumer, as a developer who's now provisioning VMs from another provider. How do I get in and manage those? How do I define my networking? How do I access that capacity coming from this external data center? That's a self-service experience. You can almost think of that also as the consumerization of IT. It's making that capacity self-service where they don't have to call up Microsoft and say, hey, I need a bunch more VMs. Can you go provision those from me? Instead, my account has access to provision stuff. I can go provision it as needed. It's that integration. What we're doing is we're aligning that self-service experience that we're building for Azure. We're making that same self-service experience available on top of an infrastructure built on Windows Server and System Center. But it goes a little bit farther than that. One of the things that's being introduced in this version is also an elastic virtualization tier, allowing you to package applications in a gallery, deploy them, and scale them under the cloud service container, much like Azure, have a virtual machine role that can scale elastically, increasing capacity and decreasing capacity. And part of the model here is to have a consistent virtualization API between Azure and on-premise. So that as a consumer of IaaS on the cloud OS, you'll have a consistent way to access and manage those VMs and networks regardless of the data center that you're getting those VMs and networking from. There's some additional capabilities I'll be able to show you today as well in this IaaS tier of how to access the VMs that is new. And we'll give you a demonstration of that. Finally, what brings us all together is another workload that we call the Service Management Portal and API as part of the Azure Pack. And what this is, in Azure, we run a self-service operation portal. Now, portal's kind of that's a multi-tier system that scales, handles a lot of load. It's a UI, but it's also a management API, and it allows programmatic access even outside of the portal. Whatever you can do in the portal, you can do through a management API, a REST API, that then talks to services running in the back-end data center. And it's a common way for accessing those services. That entire stack that we operate ourselves, so this is a stack that we run and maintain, provide support for. That stack, that set of technologies from a user experience down through the APIs, has been repackaged and bundled up as part of the Azure Pack for deployment in the on-premise or hosted data centers. And this is done so that at the end of the day, for these workloads that are included in this version of the Pack, you have a consistent model for consuming cloud services in the data center as would exist in Azure. By the way, this is also done as a white label, rebrandable solution. So even though the portal's there, it can be completely tailored to the needs of an individual organization. Let me give you a little bit of a kind of a high-level view of how we did this, because I think it helps set the frame and puts a little more context when we talk about these sets of services. What you're seeing here on the left is how Azure is built today. We have the Azure Fabric on the bottom. Running on that Azure Fabric are a bunch of cloud services, one of which is Worker Role, one of which, that websites where it says websites, that's that new website PaaS I was describing. That is this high-density web platform running in Azure that we operate as a service. The VM Role is our IaaS solution built in Azure on top of the Azure Fabric. We have this IaaS solution that we provide. We provide SQL for database provisioning on demand. We provide Service Bus as a reliable messaging platform. We provide caching, and then a whole host of other services, and the list is growing. A lot of services running in Azure. On top of all of those is what we can call a Service Management API, or for those of you that maybe have been on Azure for a while, you might have heard RDFE as a label. Basically, it is the REST API for how you get programmatic access to the services that you're consuming from Azure, from the data center. So there's a programmatic REST API. On top of that, we have this self-service subscriber portal. This represents the portal for somebody who is consuming capacity. Usually the customers coming to that portal are getting charged. They're getting billed. There's some usage data associated with what they're consuming, and they'll get billed for what they're using in the data center. But that is the consumer view of what they're going to get from the back-end data center. So let's take a look at how we're layering this with the Azure Pack. On the Azure Pack, one, we're built on top of Windows Server and System Center R2. And this is very intentional, by the way. System Center and Windows Server are the foundation for virtualization and cloud infrastructure in our on-premise and hosted environments. So what you're seeing is that is a platform evolving to support more and more cloud-centric design points for how they look at designing and providing their capabilities, so they become a first-class cloud platform. So we see that as our platform for private and hosted cloud. We then take that service management API I described, we slide that over. We have an implementation of that in the Azure Pack for deployment on-premise that provides a consistent consumption API for how we talk to stuff running on this cloud fabric that we're building out here. Then we go ahead and we take that self-service or consumer portal and we slide it over and we have it running on that API. Because now I have a consistent API. One of the things that allows me to do is pretty much take the identical portal that we operate in Azure, decouple it, take it over here, ship it in my partner's data center, or inside the IT organization. It can talk to the same API that it's talking to in Azure, but now it's talking to infrastructure running in that data center instead of running up in Azure. That's why that consistent API is so important. If we didn't do that, we wouldn't have been able to move the portal over, because the portal is stateless. Question in the back? Great question. I think I'm going to repeat the question. He's going, hey, you said pretty much. That means there's some wiggle room. What's pretty much mean? What are you saying? Well, it should be pretty obvious up front. I said we had websites, we have Service Bus, and we have SQL, and SQL is a good example. In Azure, we have SQL Azure, kind of the implementation up there. On-premise, we're actually mapping against SQL Server deployments to provide database as a service. So there are going to be some subtle differences depending on the workload. But the pattern of access is the same. And on the virtualization standpoint with System Center, we're evolving the System Center REST APIs to be identical and consistent with Azure. There are still some differences in some areas. So this is really kind of a multi-release path we're on. If you go back to where we were in January, there were more inconsistencies from an IaaS perspective. In this release with the Azure Pack and the R2 Wave, those differences are being reconciled. Something is beeping. Should I ignore that? Whack! Okay, I don't know what that was about. At any rate, so those differences are being rationalized so that they are more consistent. So today, for the set of services, you're finding very consistent APIs, but it's not all the services and workloads. So this is a journey we're on, and we're rationalizing our on-premise cloud with our Azure cloud. And also bear in mind, these things are moving at slightly different trajectories. Azure's moving really fast. On-premise, Azure we're updating like every 3 to 4 weeks, right? We're updating Azure a lot. I'm not sure we want to ship on-premise product quite that fast. There's some issues with deploying there, so there might be some differences here. And you'll actually see some features that are showing up in this release of the Azure Pack first before they even come to Azure. And then as things are updated in Azure, they'll be reflected and again updated on-premise. So there's some adjustment that's being done in real time to bring these things together to create that one consistent cloud platform across our clouds. So that's what I mean by pretty much. Hopefully that answered the question. Let's keep going on this. So I mentioned we have the Service Management API for that continuity. That self-service portal is the same portal. It's the same code that we moved over. Now, we did something that we don't have in Azure. We added a provider portal. In Azure, how do we manage the services that we operate? Like, what's our model for running our website paths that we have? How do we do that? With a ton of PowerShell. We have some internal tools that we use, that our IT organization use. Not necessarily the most friendly tools to use. We just, have a big staff that goes out and maintains these things. What we've done as part of this release with the Azure Pack is actually provide an operator portal for these cloud services that you're going to offer your tenants. And we have to do a couple of other things. In Azure, we have a standard, basically, offer that we make available to the world. Well, it turns out, for enterprises and hosters alike, they're much more attuned to making targeted offers for different audiences or segments. Or I might make an offer that's specific to one department in an IT organization. They kind of have different packaging, maybe even different SLAs that they want to offer. So we allow that kind of differentiation in the defining and bundling of services together into unique offers that you extend to your customers. All of that is done through the provider portal. So we have an additional set of capabilities that as an operator you will have an ability to tailor how you offer these services that's even more refined than what we offer in Azure. So that's another point of differentiation. But what we've set up here is this compatible frame. Notice how we've done this frame. We now have a fabric, we have a common consumption model, and some operational capability. Now what we're going to start doing is sliding these services over. So we can take these services that were built for Azure, we start bringing them over to provide similar capabilities. So in this Azure Pack release that we're making available, with the preview release of System Center R2 and Windows Server R2, we're making the website paths available. We're making the virtual machine IaaS, resource APIs, and user experience identical. We're moving over. We're providing a compatibility layer for doing SQL database as a service on top of SQL Server deployed in your data center, and bringing Service Bus over. And as we progress over time, you'll see future services lighting up. So that's the frame for what the Azure Pack is establishing, all running on Windows Server and System Center. So that's the context. Ultimately, at the end of the day, what this is driving is a more consistent developer experience between how they consume resources in Azure and how they get them from either your own IT department in your organization or from a third-party hoster. So, and that's one of the key points that we kind of want to emphasize here. When we start talking about bringing these Azure capabilities on-premise, one of the first things, or the first concerns that we hear is, please don't make me go reinvent or reinvest or have to do a whole new deployment. I'm already investing in Windows Server, I'm already investing in System Center. Is this a drastic change? Do I have to change fundamentally how we do things? The answer to that is no. This is very much an incremental approach. We're building on top of the infrastructure and the components that we're already shipping, and then evolving those technologies to support these Azure services better and better as first-class experiences. And so that's what we mean by here. This whole experience is powered by System Center 2012 R2 and Windows Server 2012 R2 and the Azure Pack as an additive layer on top of what we already are deploying and building on. So it's not a gut and replace. It is an additive experience that builds on what we deliver. So for example, this works with and operates directly with Virtual Machine Manager, Service Management Automation, or the runbook infrastructure that you're familiar with in System Center. We have great integration with runbooks. Operations Manager, with SPF, the Service Provider Foundation, and that's where we're seeing a lot of API changes and alignment between Azures at this SPF layer. Happening right now, ultimately running on Windows Server and Hyper-V. So, one, whether you're adopting the Azure Pack now or not, whether your IT department is moving to the Azure Pack or not, it's okay. They're building on Windows Server and System Center. They've got the foundation. They're going in the right direction. It's a safe investment. They can continue to build on that. And when they're ready, they can start offering these cloud services and cloud capabilities as a self-service experience to their customers. Okay, customers. Now, we do think, and we've broken this deck up into two views. We really think of the world as service consumers and service providers. And you'll see this separation. So I'm going to talk about service consumers first, and then we'll talk about service providers. What do we mean by service consumers? They consume infrastructure or apps from a provider, or they might get off-the-shelf solutions. Basically, everybody that goes to Azure is a service consumer. Now, they may be offering other services to their customers, but from an Azure data center perspective, they are a consumer. They're a consumer of our data center resources. They do need and require self-service administration. Otherwise, we wouldn't scale. If every customer of Azure had to call up our support team to get something done, we couldn't run a world-class data center. It would not scale. And it wouldn't have the kind of efficiencies that we need. And our customers actually would not be as happy. At the end of the day, we need a self-service experience. So that experience not only needs to be enabled, it should be intuitive and fairly easy for them to do, or they're still going to pick up the phone and call. So we need to provide the self-service experience in a way that they can consume. They need to acquire capacity on demand. I'll talk about this just briefly here. From an Azure perspective, we need our customers to acquire as much capacity whenever they need it as all you can eat. That's good. Now, from an IT perspective in your IT organization, they might be a little concerned about that model if they were to expose all you can eat to every customer in the IT organization. That might be a bit of a concern. When you see this acquire capacity on demand, we do provide that within the constraints, within the policies defined by an IT operator or a hoster. So I can define limits on how much capacity a customer can consume. They can consume capacity on demand within that quota and destroy it within that quota. Or they could request quota bumps from me if they need additional based on an approval process. So there is still control for the enterprise and hosting service providers that don't want to provide an all-you-can-eat style that we offer. So we're rationalizing these needs between the needs of an IT organization or a hoster versus also the customer needs of being able to provision on demand within whatever I've been approved to do. So there is acquire capacity on demand. Ultimately, it's empowering our customer to do their own operations. And at the end of the day, they need predictable costs. They need to know what things are costing them. Now, it's interesting. Providers provide the service. Consumers consume it. If they're consuming it, presumably they're paying for it. So for a hoster, that's easy to understand. You're going to get a bill on your credit card just like a customer of Azure. IT, they don't pay for stuff, right? Well, we're actually seeing a trend happening right now within the enterprise, and that's this chargeback model, where basically we're seeing a chargeback model happening where IT organizations are basically evolving to become hosters within their enterprise. And they're doing chargeback for different departments. Here's what you've consumed, here's what you're being charged, or here's what you're budgeted, allowed to consume, and that's all you're going to be able to consume. And when you need more, and you get the approved budget, and we've built out the infrastructure, I'll update your quotas so you can now get more capacity. But at the end of the day, they're still being charged, but it's more of a transfer and accounting process than a credit card thing. So there is still fundamentally this idea of tracking usage based on a customer subscription model, whether I'm charging a credit card or charging the billing, the accounting department. There's still this model that's in place. And ultimately, customers need to get up and running quickly. And we're seeing that over and over again. Matter of fact, one of the problems that we often see in the enterprise right now is kind of rogue IT, this asset sprawl, where basically developers, maybe some of you guys are here, and so I apologize if we're getting you in trouble, but we see a lot of application developers basically going around IT because it just takes too long. And they'll go out and either go out and buy the hardware and shove it under their desk, or they'll go out to a hosting service provider and use a credit card that they got for a corporate card or something and just go get some capacity out of band. So one, the reason they're doing that, they need some agile. They need to be more responsive because sometimes a VM request may take months, weeks or months from their IT department. So they need it. They're trying to get their jobs done, so they'll go out of band. IT organizations see that problem. They want to be able to provide more of a self-service experience. So this tries to rationalize those two needs, make it easy for the customer to come in, but still allow an IT organization to have some way to model that consumption and put some controls on it. Okay, we've talked about consumers. Who are the providers? Okay, that's the IT guys. That's your data center, that's your IT team, or it's the hosting servicing organization. At Microsoft, it's our data center. We're the service provider of Azure. But it might be the IT department in your organization, and it might be an operator at a hosting center. They provide these services. Their focus is a little bit different. What they're optimizing is reducing cost. They want to provide as much capability as they can at the lowest cost. And that is true for both hosting providers and for the enterprise. And let me give you an example here. Remember we talked about IaaS and this cloud PaaS. Hosters have always been interested in getting high-density hosting there and reducing costs for their web tiers, the presentation tiers. Well, what happens in the enterprise? You know what typically happens in the enterprise? Every website winds up on a VM. So now you get a bunch of VMs being spun up, all running IaaS, basically way overkill. You've got a bunch of VM, you've got VM sprawl, all running one or two sites. Very inefficient, driving a huge cost into the IT data center. And when they look at that, they actually would like to have a higher density solution where they can consolidate that on a web PaaS. Now, they don't care about whether that's self-service. They don't care about making that more efficient for the customer. What they're really cared about is that VM sprawl and reducing the cost to provide that service. And that's one of the workloads, so there's a benefit in this for that scenario as well. They also want to maximize that per customer profitability. They're interested in hardware efficiency and automating everything. Because if they can automate it, that, again, increases the efficiency in their data center. And differentiated SLAs. And for hosters, that's very obviously important because they might have a free offer, which they run on commodity hardware. I'm not going to put my big iron behind that. I may have an offer that I do for a high-value customer that's going to pay me a lot of money, so I'm going to put in some nice racks with some nice hardware for that customer, and I'm going to charge differently for that. So we mean that by different SLAs. But you know what? Even in the enterprise, you have different SLAs. Your IT organization may provide a different set of capacity and different machines for a dev test workload than they might for their billing or for their payroll system or their taxing system or their accounting system. If they have a production workload in production, they're going to have a different hardware profile that they use for that. So one of the things we recognize, this is one of the advantages of the on-premise cloud, is this differentiation of SLAs by workload. That is something that you don't find very often in a public cloud. That's one of the differentiators. Okay, we're now going to get into the focus really on the consumer for the next part of this. Again, just to set it straight, these are people and developers that consume cloud services, typically developers and IT pros, self-service. This is just a repeat of everything we've been doing. They build and deploy, and they pay for the services that they consume. Now let's get a little bit deeper about the services that are in this release. First and foremost is this websites service, this new PaaS. And again, this is a platform. It is a PaaS service in its own right. It is the same platform that we run in Azure. It is not a single machine. It is a multi-machine, multi-tiered PaaS. It has a data tier. It has a compute tier. It has a load balancing tier. It has publishing endpoints. It is a full-blown application, multi-tiered application in its own right, targeted at providing highly scalable web applications. It provides quick iteration for developers to integrate with source code control so they can iterate on their applications well. What does that mean? That means that the platform itself, built into it, is the ability to talk to a variety of source code control providers, and we'll see a demo of that in just a minute. As a consumer, as a self-service experience, I can manage my application, getting real-time telemetry, scaling my application, and have some ability to manage the site that I go out and publish. And as a platform, built into that platform is support for a lot of open source and standard web technologies from .NET, Node.js, PHP, and Python. Now, as an operator, here's what that means to you. You don't have to deploy and configure those. You just deploy the web PaaS. The web PaaS has built-in support for all of those technologies. Your customers can use them right out of the box and start deploying their applications that support those frameworks. So you don't have to get into the semantic differences or configuration differences of how to get this set up and make it run in a cloud platform. It is part of that PaaS platform. And it's the same way that we run it in Azure. And this is an example of what the self-service experience would look like. So is anybody here tried the new website PaaS in Azure today? Okay, one person. This is what you would see if you went into Azure and managed the site, is that same experience that we're making available to consumers of this service for on-premise and hosted clouds. Service Bus. It's great to have a presentation tier, but a lot of these applications need to communicate to another system. And this is really important in the enterprise and a lot of commerce applications. Actually have a commerce system that's on back-end legacy hardware, another system somewhere else, and you have to go through this. And you need a way to gather the storefront information or whatever you're using to collect data from the front end and basically get it in a reliable manner to your back end. And Service Bus is a tool to do that. It provides this reliable messaging with guaranteed message delivery. It supports standard published subscriber messaging patterns, and it does use standard protocols from REST, AMQP, and WS. And it's interoperable between .NET, Java, JMS, C, and C++. And why is that important? Because not every client, publisher, or subscriber is going to be on the same platform. It might be on a Linux platform. It may be on an old mainframe. It may be on a different language set. So it supports a variety of access points for both the publisher and subscriber to get it. And it now has complete integration through that management stack, through that REST API, that service management API, and the UX, the same integration that our customers will have from Azure. So if you have a customer who's developing an application on-premise and then goes to Azure, they'll get the same experience, or vice versa. Just to give you an example, this is the Azure dashboard, and it's the same dashboard provided on-premise for getting into Service Bus. Now, infrastructure as a service. Windows Azure IaaS is now GA. It provides a user experience, a set of APIs for doing VM provisioning with a gallery of VMs. We now have that consistency there. We're introducing a new capability called Virtual Machine Role. This capability was designed in conjunction with the Azure team that provides a way to scale VMs elastically and define those in a metadata format where you can define separately the container that it needs to run in and then the application configuration parameters that need to go with the application. So those can be deployed and then scaled. So you can scale a virtual machine application and scale it based on demand, and it works for both Windows and Linux with full gallery support, so you can have a catalog of these applications available for your customers to come and consume. And by the way, these are curated. You can have unique galleries on a per offer type. And we had an interesting case where one of the customers was looking at providing, essentially, this was in an academic forum where they were designing class curriculum, and for each class they needed a set of templated deployments of an application. They could actually, in this case, define an offer type with a set of templates, each one of those packaged in a gallery. The students can come in, provision those, and then scale those out on demand. But likewise for the enterprise, for loads there, they can be defined and put in a curated gallery by an operator. And you'll see some fun capabilities in that. The next is virtual networking, allowing customers to come in and define their own networking. As a service provider, you can define baseline virtual networks that you make available as part of an offer, and allow customers to come in and define their own virtual networks, and even enable site-to-site networking. So in Azure, we have a feature called Azure Connect. What does Azure Connect do? It allows an enterprise to basically stretch their on-premise network into Azure so that VMs that they provision in Azure can be on the on-premise network, basically providing a gateway between the VMs that are running in Azure and their on-premise network through Azure Connect. As part of the Azure Pack and integration with System Center, there's now a feature called site-to-site connectivity, which does very much the same thing. It allows you to establish your customers to establish a gateway between the VMs that they're provisioning, the networks that they've defined in their cloud instance, and an on-premise network. Now, that's great for a hoster, but that's also great for the enterprise where you have distributed data centers and maybe customers that need to do this gateway connectivity between their installations. Now, there's some additional capabilities that are, and that's an example of the UI for the virtualization. There are some additional capabilities that are part of this release. When we did the release very early on with SP1 back in January, we put a little caveat on that release. We said, hey, look, we're putting this technology out there. We want you to get familiar with it and get introduced to it, but we put a little tagline that said, for service providers, basically for hosters. We consciously excluded the enterprise from that statement. Now, why did we do that? It turns out we actually had a lot of interest from enterprise customers in January, and we were kind of excluding them, saying, well, this is really for hosting service providers. It's not ready for the enterprise. We had a bunch of enterprise partners that went out and deployed it anyways. But there was one critical feature that was missing in January. We knew it was missing. We just didn't have time to get it done with that release. And that was critical for the enterprise. That feature that was missing in January that is now part of the Azure Pack and the R2 Wave is integration with AD. You've got to have AD if you want to go in the enterprise and have a self-service experience. And that's what we've got in this release is integration with Active Directory, support for ADFS, and co-administration. Some key concepts that are just critical for enterprise adoption. They weren't required for service providers, and that's why we did that focused release in January. But now we've rounded that out with great AD integration. We'll give you an example of that coming up. We now integrate also with SQL Server and MySQL as data tiers for self-service database provisioning. And those are integrated in the Azure Pack. And one of the nice things that's coming in the R2 Wave that didn't exist before is support for SQL always on. So as an IT operator, if they're going to provide a SQL cluster and make the database available, and they want tenants to be able to come in and provision databases on demand, they can offer SQL always on to make databases highly available across the cluster, and that feature is now compatible with the Azure Pack. They can also have these other curated services in the gallery, offer other unique services that are from that provider. Ultimately, at the end of the day, there is programmatic access to these cloud services in an Azure-consistent REST API. Okay, enough slides. Let's put a little bit of this in action and take a look at what it really looks like. Okay, since this whole thing is predicated on having a consistent cloud platform between Azure, between on-premise and the hoster, I want to start by showing an experience in Azure. So I'm just going to try to set a baseline. Let's take a look at what one particular experience looks like for a developer going to Azure. So use that as a baseline. I'm now going to go log into Azure, but I'm going to do it a little bit differently. In Azure, Azure supports what we call organizational ID. And so I can actually bring my corporate identity. I can log into Azure with my Microsoft credentials as a Microsoft employee through that level of integration. So that's what I'm going to do here. I'm going to log into Azure with my corporate identity. And the first thing you'll see is this login page. Now, where did this page come from? This is actually a page hosted by our IT department, MSIT. They host an ADFS node that is for employee access to corporate resources. Okay, so if I want to get access to our health network or to our employee page, I would log in externally through this portal. It's the auth portal for bringing my corporate identity to those resources. Azure supports the ability to get that identity through this same model. So I can log into Azure through this corporate portal. So that's what I'm going to do here. I'm going to log into Azure. Let me just see. Yep, I'm going to log in. So I provided my Redmond credentials. I'm now logged in, and now I'm logging into the Azure portal with my Redmond credentials. You'll notice in the top right it says bradleyb@microsoft.com. Okay, so I'm now logged into the Azure portal. This is what Azure looks like. This is our production 24/7 service. These are all the services on subscriptions that I have access to. I can go in and start provisioning and doing stuff in Azure. I'm going to go ahead and do that. I'm going to go to Azure, and I'm going to create a brand new website. We'll just do a quick create on a website. We'll call it TechEd Music Store. Sure, that sounds good. Let's go ahead and create this. Now, we're creating this TechEd Music Store. Now, what's happening on the back end, it's not spinning up a VM. It's not running a bunch of automation to spin up a VM and configure IIS. What it's doing instead is it's talking to that web PaaS and it's saying, hey, provision a new site on that PaaS. So no new resources had to be allocated, just the provisioning of a site within existing resources for the serving up tied to my subscription and my credentials so that I have access to that site. It is now there and been successfully provisioned. I can now go into a management dashboard for that site where I can see and do different kinds of configurations on that site. One of the things I can do with that site is integrate with a source code control system. So let's go ahead and do that. I can pick, when I set up integrated source control, a variety of source code control solutions, whether I'm using Codeplex, Bitbucket, Dropbox, GitHub, or a local Git repository. In this case, I'm going to pick Git. And what this is doing for the site that I just provisioned, it's actually provisioning on the back end a Git repository for that site, specific to that site in Azure. So as part of the PaaS, there is now a version to Git repository dedicated to my site. That process has been completed. I'll dismiss this UI. And now that it's completed, it's given me basically essentially a Git URL endpoint, a publishing endpoint for the repository in Azure that is now backing my site. I have, on my local disk, a Git enlistment. This is a Git project that I've cloned from GitHub. So I'm collaborating with another developer out on the internet. I've cloned it locally. What I'm now going to do is add my Azure Git enlistment to this, or publishing endpoint. We'll call it Azure, and I'll paste in that URL. It's now there. And now I'm going to push content from my local enlistment up into Azure. What it's doing is saying, hey, push up into Azure, the connection I just created, the tip of my local enlistment. So now it's going to start that process. And by the way, it's worth pointing out here, first thing I need to do is provide my publishing credentials. So I'm going to go ahead and do that. So now that I've provided my publishing credentials, it's going to start the publishing process. It's worth noting, by the way, this isn't like a Microsoft version of Git. This isn't like an Azure version of Git. This is the standard Git client from the GitHub archived from the open source project, so this is just standard Git that anybody else could download. But now it's working directly with that website paths that we run in Azure. It knows how to set up a Git repository. It knows how to have a publishing endpoint that's Git compatible and receive the Git content. Notice that the website's already recognizing that it's getting a new Git deployment, recognize that it's being deployed, and that now the deployment has completed. So now that that's been published, I can go in. Matter of fact, if I were to look at that, I'd see a complete versioning history, if I were to drill down here, of all the activity. Over time, you'll see all the activity that's happening to this site, built into the WebPaths platform. I can go in, if I were to hit this dashboard real quick, I'll get the endpoint for my site. I can go in and hit that website and just see, did it in fact publish up into Azure? Ooh, Azure had an error. That's interesting. Don't know what that's all about. I'm going to ignore that for a moment. Now it'll be interesting. We'll try this on premise and see what that looks like. I'm going to switch over here. One of the things, by the way, to publishing a website and getting up and going isn't rocket science. Well, apparently it might be. But one of the things that makes it unique is the ability to scale, which is to scale that application elastically. One of the things you can do with a site that's been published to Azure is to scale that. So I can go out and I can move it from a free tier into a shared tier, or even into reserved. I'll talk a little bit about reserved. And then I can scale my application from 0 instances to 4 instances, or whatever my IT operator has allowed me to do. In this case, because it's Azure and on this, I can scale it quite a bit. But I don't have to redeploy my application. It'll automatically scale to handle that load. And that's what makes it a cloud. I can also transition from running in a shared environment where I'm sharing the same compute capacity as other tenants. I can run in a reserve mode where I get dedicated instances for my site and even pick what capacity I want my sites running in. So I can run in a small, medium, or large, hit save, and again, I don't have to redeploy my application. By simply making these changes, I move between different SLA boundaries, and I can still scale my application. And that's how we run these services in Azure. I'm going to take a quick look now. Let's take a look at on-premise. Let's just take a look at what the Azure Pack does. I'm now going to go to a deployment of this Windows Server, System Center, and Azure Pack. And this stack is not running in Azure. It's not even running in a Microsoft data center. We've taken a couple of Hyper-V servers that we're running at SoftLayer. So we're actually running a mock lab over at SoftLayer. So we're living the dream here. We're going to a real third-party data center, deploying the technology. Let's see if we can make it all work. Okay, so that's what we're doing here. This is a real deployment in a third-party data center. Now, in this particular case, we've configured it to allow 3 different authentication models. I can neither be authenticated directly against AD that we're running there in that environment. I can be authenticated using ASP membership. This would be typically a hoster scenario where they're basically doing email validation. You just provide an email address and a password and you're in. Or, in this case, we've configured it to authenticate against the Microsoft corporate IT login. So I can log into this installation with my corporate identity. So I'm going to go through that. And again, this is all based on configuration and how the environment is set up. So I'm going to use the Microsoft corporate identity. Notice that I'm getting the same login page from Microsoft that I got when I went to Azure. So I'm going to log in. And this hasn't been modified, a different version. We didn't make a copy of it to make it look the same. This is our corporate login page for all resources that I want to get CorpNet access to. So I'm going to log in here. Okay, and now when I'm logged in with my corporate credentials to the deployment of the Azure Pack with System Center and Windows Server running in a SoftLayer environment. So here I am. I'm over there. I'm running in this environment. Notice over there I'm bradley.bartz at microsoft.com. I'm logged in. Let's take a look at that same experience and see how it goes there. So we'll go back to the websites here. Let's provision a new site. I'm just going to repeat exactly the same steps. Website, quick create. We'll call it TechEd Music Store. Okay. I pick a subscription. I have it provisioned. I actually have a couple of subscriptions, and I'll talk about that and why that exists. But again, this is doing the same thing that it did up in Azure. It's provisioning that against the PaaS platform. It's already done, and it's up and running. So now let's go ahead and hit that site. You'll notice that I have, when I hit it, I get the same management dashboard. I'm going to now do the same thing. I'm going to set up an integrated source code control. I have all the same options here. I'm going to go ahead and pick up a local Git repository, just like I did up there. I picked a different subscription. Okay, so I got to give it a username. I must have got a password wrong. Let me step back up here. I wonder why I'm getting that. That's interesting. I don't have explanation. We just made a change to this environment before coming in here, so I might be seeing some ramifications of that change. But at any rate, we now have a Git repository set up for TechEd Demo 2, just like we did in Azure. I have a publishing endpoint. I am now going to take that publishing endpoint, and I'm going to go to the same enlistment that I had that I just published up in Azure. I'm now going to do the same thing. Git remote add. We'll call this one Contoso. And I'll add that publishing endpoint. There we go. Now we'll do the same thing. Git push Contoso master. You get the publishing credentials. Provide that. And the same process is happening that it happened up in Azure. You notice that it's still doing the packaging, getting ready deployment. You notice that the back-end platform recognizes the deployment is happening, and it's now receiving the bits. And they're being deployed up there in real time. So far, as a consumer of CloudOS, I haven't had to do anything different between running in Azure and running on the Azure Pack with Windows Server and System Center. I'm getting a very consistent experience. As a matter of fact, I used the very same enlistment that I just published up into Azure. I didn't change a thing, except added another connection. If I were to go into here, I've got the same versioning history and control. If I were to go to the dashboard, now let's see, this is a real test here. I'm kind of curious to see what's going to happen. Let's hit the endpoint that just got deployed here up to the environment running at SoftLayer with the Azure Pack, Windows Server, and System Center. Ho-ho, the site works. So yay. Even better. That's nice to see. So there's the site that I just deployed up and running. But it's not just a site. Just as with Azure, I can go in and configure and scale that site. So if I were to go hit scale, I can run it in basically a small SLA on a free tier, just like I could in Azure. I could run it on a higher capacity shared environment, or even go into reserved. And in each case, here I could pick my compute size and still scale. So I have the same experience, the same management capability of being able to have an elastic application that is consistent on that consistent cloud platform, regardless where I deployed it. Now, one of the things that I wanted to show is that's unique here is we also have co-administration. What co-administration does, it allows me to share my subscription with other developers that are running in the environment. So I could have another developer share the resources so we could work together as a team. Likewise, they can share subscriptions with me. And we do this in Azure. Today there's a co-admin feature. You can make a co-admin, assign one of your teammates to be a co-admin on your subscription so that you two can collaborate on the same site, on the same VMs, have access to those resources. What's different in the Azure Pack, we support that scenario very much like it does in Azure. You and I can provide each one of our credentials and we can share a subscription. But what we've done different here for the enterprise is actually allow you to associate an AD group as a co-administrator. And this is really great. So you can manage membership just through AD like you do normally, but that AD group can determine who has access to the set of resources coming from the IT department. In this case, Mark has actually made me a co-admin for his subscription. Let me give you an example. His subscription is right here. If I were to turn that off, you'll notice right now that I'm going to see the website that I created. I see my TechEd demo. I see these virtual machines. I see no virtual machines. Nothing is there. I have no networks. I do have Service Bus. And actually, Service Bus isn't even on my subscription. I'm getting that from another developer who shared me his account for subscriptions. I'm going to go back to that subscription that I turned off and turn it on. This is coming from another developer. That developer has set up a bunch of VMs. Because he made me a co-admin on his subscription, when that subscription is enabled, I will see those resources on that subscription. In this case, I do. I see all the virtual machines and networking now light up. So those are actually provisioned by his account. He is the owner of these resources, of which I'm a co-admin. Now, here we have an Azure experience for provisioning VMs. It's very similar to Azure. You can go in and you can say new VM. I can say new virtual machine and create a VM from a gallery, or we have these new virtual machine roles. And I'm going to show you what a virtual machine role is. It's basically, these are templates that are IT defined or hoster defined that they want to make available for self-provisioning, but each one of these can scale. These are all designed to have that elasticity of the cloud. So for example, if I were to go in and I wanted to do a dedicated IS installation, let's say. Website paths is nice, but for this particular workload, I'm just going to a bunch of dedicated VMs. I'm going to do traditional web hosting. I can go ahead and pick this. I could give it a name. It's going to be a full-blown portal. Notice that there's this versioning tab. That's going to be key and come up later. These templates are designed to be versioned and supported by an IT or hosting provider. In this case, I'm going to just pick version 1. And since there are multiple subscriptions, I can pick which subscription I want it provisioned against. Here, there's some initial parameters about the container. This is the VM tier that it's going to get deployed to. What's the instance count? What's the maximum instance count? So it can be deployed initially as 1 instance, but scale up to 5. I could say, oh, I want it initially scaled out with 3 and max to 5. And then I can pick which size of VMs am I using, small, medium, large, or extra large, for what kind of VMs are going to be provisioned. These are provider defined. So your hosting provider or your IT department can decide what side cores they're going to make available. The OS instance I'm going to make available. And then I can provide some admin credentials. Okay, once I have those names that match, and go on. Once I get past this screen, oh, must contain, okay. The next set of settings I get are basically application-specific settings, and these will be unique for every application in the gallery. So this is where I put in the configuration data for the type of application that's going to be deployed across that virtualization tier. So in this case, there's IIS, so I can give it a site name, a website pool, and a port, but these are all configurable in the template. So we could have added additional ones here that maybe they're unique to the web application, maybe they're unique for deploying like a SharePoint farm, or any other kind of resource. So these are defined on a per template basis, and then we can do the deployment. Because that deployment takes a little while, though, I'm going to show you one that we've already deployed, FinWeb here. So this is a virtual machine role that's already been deployed. When you log in, you'll see a bunch of parameters about its usage, how many cores are used, its RAM, storage, the devices that are attached to it. In this case, it has a NIC, there's a disk with the Windows image and a blank disk for a data disk, all there on that image. And I can scale it. If I hit the Scale tab, this was deployed with 2 instances. I can just scale it out to 3 or 4 instances. When I hit Save, that'll happen in real time. That'll be automatically scaled out, the application provisioned and configured to be in a consistent model. So this is where I get just like with the websites, I could scale a website. Here I'm scaling a virtualization tier. And I can move that out. But let me go back. Do you remember that versioning option when I went to deploy it? In this case, it says that there's an update available. So what an operator can do, or an IT department, as they have a template deployed for a certain workload, Maybe there's a service update or an update to that application or the template or the configuration for that application. They can publish that update into the gallery. Each of the applications that were deployed with that gallery will get notice that an update is available. Then me, as the application owner, can decide based on my servicing window when to deploy that update. So I could say, hey, I want to deploy that update now, hit update, and deploy that update, and it'll be rolled out safely across that virtualization tier to update it to the updates that are in that pack. So this provides a servicing opportunity that is on an approved update from an IT or hosting service provider that can be individually deployed by the consumer when it's appropriate for that consumer. So there's an example of a set of IaaS experiences. I want to show you something else that's super cool. We can always RDP into a Windows box. We've been doing this forever. You can RDP as long as it's on a public network. And if you're inside the enterprise, you might use a KVM switch or something just to get to the raw machine when you don't have RDP enabled or something like that. One of the problems we have with a lot of hosted environments is how do I get access to a VM? One, what if it's not on the network? Now, that's pretty tough. And KVM, most hosters are not going to provide access to the Hyper-V host in a hosted shared environment to give you access to it to go get to your VM. You're just not going to get there. So in many cases, it's very difficult to get to VMs running in other data centers. It can be a challenge. As an example of that, and matter of fact, if you're running a Linux, which doesn't even support RDP, remote desktop, you can't get to it unless you go through SSH or something like that from the command line, provided, again, it's on the public network. So there's a new feature that's coming in this release of the R2 Wave. So it's coming as part of the Windows Server release. It's been updated as part of System Center up through the SPF layers and into the Azure pack to allow what we call Console Connect that works independent of whether the VM is on a public network, independent of whether it's even got the OS installed, and whether it's Windows or Linux doesn't matter. So in this case, I'm going to go into a Linux deployment. Okay, so this is a Linux VM. I'm going to pick Connect. Now, normally it would just do an RDP remote console, which doesn't work on Linux, so that wouldn't work anyways. But instead, I'm going to pick Console Connect. Now, Console Connect will go, hey, look, this is going to download an RDP file. Do you want to do that? Do you want to accept this RDP file? I'll say yes. I'll go ahead and accept that, and then open the RDP file. This is now going to do a remote connection. It's doing a Console Connect through a secure channel, and it's going to give me console access to the Linux installation running in the data center. So here I am, logged into a Linux machine through the portal there, and that is something you can't even do in Azure today. So that's a new feature coming in the R2 Wave integrated through the stack. And that is something I'm doing now from a Windows desktop without even going through SSH. So I can just get remote console, and it didn't even have to be on the network. Case in point, let me go ahead and log out of this. Hopefully I picked the right one here. Nope, picked the wrong one. Let me go back to my desktop. Go back into the client. Okay, this is my demo machine. We should be right back here. Which one did I click last time? It's the right one. Yay. All right, that was the right one. So you just saw me remote into a Linux box. Now let's log in to a different box. We're going to log in to a Windows Server 2012 box. We're going to do the same thing. Now I could just RDP to this box. But if we go down and look at the attached devices, you notice that there is no NIC attached. This Windows Server installation doesn't even have a public network on it. It has no NIC attached to it, and it has just a data disk. So I couldn't RDP to it because it's not even running on a public network. Let's do a console connect to that image. So I'm going to do a console connect just like I did when I was going to the Linux box. I'm going to remote in. And now, notice where I am. I'm logged into this remote box that is actually through a failed boot sequence off that thing. So I can get in and troubleshoot an image that's running in the data center without even being on a public NIC. That's all being made available through this Azure Pack System Center and Hyper-V stack that's being updated. So that's a great new feature that's showing up in the on-premise deployment of the Azure Pack and System Center even before you see it in Azure. All right, before we conclude here with the session, so far we've been talking about the set of consumer experiences. In the time that remains, and I'm just even going to skip some of the slides here, I want to show you what the provider experience looks like, just so that you have some familiarity with what's there. So in this case, I'm going to log in to the admin portal. Now this is giving me a different authentication model. This is using Windows Auth, and this can be configured, but typically the administrative portal is only running inside the firewall. It's running inside the operations center that is providing the cloud services and not typically exposed over the internet. So now I'm going to log in. Now the first thing you'll notice is that the operator portal is running the same portal framework as the tenant portal. So this is running the same UI infrastructure, but now it's managing a different set of objects. Instead of managing websites and virtual machines and virtual networks and databases and things like that, it's managing a website cloud or clouds. It's managing VM clouds. It's managing SQL Server deployments. It's managing service bus deployments or service bus clouds. It's interacting with automation runbooks for configuration. So this is an operator view, but it's in the same portal framework. A couple of things that pop out of that. This portal framework is actually designed for reach. One, it's tenant-facing or customer-facing, so you want to have broad reach, support for all the browsers, support for devices and tablets, and that broad reach. Operators benefit from that same broad distribution so they can have reach as well. But now if I were to go in and look at, this is where I would manage one or more of those website paths that are deployed, and I could go in and look at any one of those, and I could go look at all the machines that it's deployed on, or I could go look at the websites that are running against that site for all the tenants. Here are all the machines that are deployed as part of that web paths running in my back end. Here are all the sites that have been provisioned against it. I can see all the customer sites and filter by subscription or do troubleshooting with those. I'm going to go ahead and back out of this for a second here. I can go manage my VM clouds. In this case, I'm connected to a SPF, which is a Service Provider Foundation. It's part of System Center, provides REST access to the back-end infra. It's connected to that, and I can go manage the clouds that have been configured through Virtual Machine Manager and get access to those clouds and see how healthy they are and what's been deployed against them. I have access to those resources. Likewise, I can look at the number of service bus deployments that I have and what their health is, whether I have one or more. I can look at SQL servers. I can have groups of SQL servers that are being made available for tenant provisioning of databases. We even allow the integration of MySQL into the stack, and this is part of the web gallery support. A lot of applications such as WordPress actually use MySQL as a data end. Well, that will integrate into the solution as well. And our automation tab, this is where we integrate with runbooks that are running in the service automation engine part of System Center. So I can go and look at the runbooks that are deployed. I can go in and take a look at any one of these runbooks, and not only can I drill into it, I can actually write in the browser, I can go ahead and edit and author and change a runbook and have it in various states. So I can edit jobs, see what jobs are running for this workbook, schedule them, manage the automation that is running in my back-end infrastructure. You can even have automation runbooks tied to certain events coming from Virtual Machine Manager so that you want to do some provisioning of new hosts based on alerts that are happening as the system starts to get overtaxed and reaches some threshold. You can have it add new hosts or make those available. So there's a bunch of basically what we consider kind of multi-tenanted services or infra management kind of capabilities built into this, the operator portal. And then there's this little thing called plans. Plans is where, as an operator or a hoster, they decide what tenants will have access to and how much they'll get access to it. So in this case, we were logging in through a platinum plan. And in the case of the Platinum plan, it was configured to basically have the website cloud, virtual machine clouds, and SQL Server. Now notice that the Platinum plan didn't have Service Bus. It could. That's just how this plan was configured. I could do a plan that is just for IaaS. When you define a plan, you pick the set of services you want to make available, and then for each service, you define a set of constraints. Any subscription to this plan is going to go against this specific instance of SPF. I might have multiple. This specific cloud, what cloud I'm going to connect to. You can start to set quotas. How many virtual machines are they allowed to get access to on this plan? In this case, it's configured for 20. How many cores do they get? How much RAM do they get? They're basically, you're defining a set of constraints as a subscriber that they're going to get access to, what hardware profiles they're going to have, and even down to picking what templates are going to be available for VM templates and which items in the gallery are going to be available. So per offer type or plan, you can curate a specific set of templates or gallery items together that they'll have access to. Define all that, package it all up, and then a plan can either be, at the end of the day, it can either be a public or private plan. I'll clarify those just a minute. A public plan is something that is available for self-service subscription. A customer can come in and subscribe to that public plan as they want. This is what a hoster would do. They might have a free public plan. Come in, try it out. We want you to get easy access to it. And then I'll upgrade you to another plan. Then there can be private plans. Private plans are not in a public gallery. You can't subscribe to them on your own, but I've defined them. If you want subscription, I will manually assign you to that plan. The intersection between a customer and a plan equals a subscription. That is your subscription ID. So you may have one or more subscriptions depending on the offer types you have access to, or you might be a co-admin and have access to another subscription. So this is where you map basically a set of capabilities to back-end infrastructure. The plan is what does that mapping. I might have one plan, for example, my Platinum plan, that is mapped to a very robust cloud I'm running on Big Iron. I've set up in Virtual Machine Manager, I've gone and mapped and set up a cloud on some really big machines, some honkin' Hyper-V servers. I've just got it on some really fast storage. I've just done a premier deployment. I call that my Platinum plan. I'm going to use that for production workloads, or if I'm a hoster, I'm going to use that for a high SLA that I'm going to charge a lot for. I might define another cloud running on commodity hardware, on lower-end hardware with a different SLA. I'll define a different plan for that. So these two plans are unique offers. They map to different hardware on my back end. Then I can basically manage users for which offer they subscribe to, one or others. As they provision websites, databases, or VMs, they'll be routed to the appropriate cloud or the appropriate definition of where those services are running in the data center. So the plan is how that is orchestrated and made available. But at the end of the day, it just looks like a subscription to your customers when you come in and consume that. And then finally, you get a list of all the customers that are coming in and have subscriptions against your resources, where you can actually look at the number of subscriptions. You can assign co-administrators, the NT groups as co-admins. You can even go in and suspend a subscription or suspend a user so they will no longer have access if you need to, and get those kind of controls. So that's all done through the service provider portal. So that's really the provider side of the equation and the consumer side that you just saw. At this point, I kind of want to open it up to any questions that you might have in the time that remains. But that's really the overview. So you've seen both consumer and provider views of the two experiences. I'll switch back. Let's kind of jump to the end here. The key thing to remember is it's all powered off a Windows Server System Center, built on what you know, and it brings that set of Azure experiences, learnings, and technologies to the private hosted cloud. Ultimately trying to deliver this consistent Cloud OS set of capabilities to the customers. Application developers, again, shouldn't have to know or concern themselves about these things being fundamentally different. It's the consistent, like that website experience, fundamentally it's the same. Same experience whether I was going to Azure or going to the on-premise deployment. Same with provisioning the VMs, remoting the VMs, and managing those VMs. Okay, with that, that's about all I have. So backups would be through the System Center virtual machine. So the same way you would back up through System Center today is how the system would be backed up. So again, that's one of the advantages of building on top of Windows Server and System Center that already provides how we do disaster recovery, how we provide backup and servicing. They provide tools for doing that, so we build on top of that so those same processes would continue to work for these workloads. Yes, sir. Yes. Yeah, so the question was, If you're a System Center customer and this R2 upgrade, what's the story? Is that an in-place upgrade? R2 will upgrade on top of System Center SP1, and then the Azure Pack is a download that you can install and work with the System Center R2 release. Yes, sir.
From the bottom, I saw it's very easy to create a new website.
Yes.
What about the fine-tuning of the website? So if I'm IAS, I have so many different options.
Yes.
So much stuff to configure.
I didn't show it here, but there is a configuration tab where you have a much finer grain where you can set like your MIME types and a bunch of other things, so a bunch of options you can configure.
Does it mean I have a subset of the options that I have in IAS, or do I have the full-blown options?
I think there's a lot of options to the UI, but you also have the configuration database, or the metadata, the config file that's part of the application site that you can put a lot of settings in as well that will update IS.
Kind of the template.
It's a hybrid, yes.
It's a kind of template, like you showed the template from the VM. It's the template from the website. Part of this template is the web config of the
Yes, yes, very similar to that. It's identical to all the configuration options we provide in Azure. We haven't done a subset, so it's the same configuration options you would get in Azure today for doing websites.
One last question. Also for the template that I saw from the VM.
Yes,
If I install my own services
yes.
on that machine, do I have a way to make my own template, my own field show up?
Great question. So the question was, we just saw the gallery and a bunch of items and templates that could be installed. Is there a way for me to create my own templates and define my own applications that need to go in the gallery and define which parameters are specific for my gallery items? And the answer to that is yes. Those templates are actually authored as JSON files. We don't have a tool to produce it, but it is basically a text JSON file. We'll have examples on how you can author those, and you define the parameters. There was a session yesterday or the day before where Eric Winter from the System Center team actually did a presentation on how to author those files. So absolutely, and in the service management, service provider portal I showed you, under VM Clouds, there's actually, you can import one of the JSON files that you author externally, import it in and add it to the gallery. Once it's been added to the gallery, you can include it in one or more offers. So absolutely. Application and the container. So you define the container, the virtual machine role, the parameters, the hardware profile, and the application settings are all part of that JSON file.
What form does the application deployment take if you're trying to take the step of building an application and deploying it and update out to the VM? How does that?
I would have to defer that to the Windows Server, the System Center team on the JSON specifically. I don't want to give you any wrong information there on the exact details. But it does reference existing images that are in the archive, in the library that are there. The application settings, I believe, are, well, I don't want to give you an I believe. I'd rather give you the real stuff. So, yes?
I guess the gentleman with the backwards question kind of answered the private file manager problem.
Yes.
But on our web servers, we quite often get attacked by malware or virus or whatnot. If you deploy this web service onto the public cloud, how do you protect?
Yeah, so the question was, right now, when they deploy their IIS servers, they're getting constantly attacked by malware or other things attacking their servers. If they deploy in this web PaaS, how do we secure our environment? I think that's what your question was. And as a PaaS, there's a load balancer in front of it and firewalls you can define and set up. And we even allow those websites to be individually configured with SSL, so you can define certificates to try to provide secure access to those sites so they're not as susceptible to spoofing. But it's very similar to what you would have to do with any other deployment as far as defining your firewall and your access to that PaaS. It all is routed through a load balancing tier, though. So as long as that is protected, none of the worker nodes behind have direct internet access. They're not going directly to the individual workloads behind it. It's all going through a load balance tier. So that's where you need to put your security firewalls in front of.
Currently, we run the endpoint protection on all of our servers. There's nothing like that on the
You run what?
endpoint protection.
Endpoint protection?
Yeah, and there's nothing like that on the private cloud side.
So one of the interesting things about on-premise deployments of this PaaS is you have a little bit more control about what you deploy on each one of those nodes. So there's actually a feed of what gets deployed in that cloud PaaS as you scale them. And so you can actually add additional agents. If you want additional agents running on all those nodes, you could deploy those as part of the fabric when it gets expanded. So you could modify that specific to the needs of your organization. This wouldn't be as part of the public cloud. It would just be the on-premise. Yeah, on the Azure public website PaaS, there is no way you can install anything on those nodes. There's no direct access to those. Unless you do your own VM IaaS. If you do your own VM IaaS, you can install whatever you want there. So if you go provision your own virtual machines in Azure and set up IaaS there, then you could configure those. Okay.
Can you comment a little bit on the future of worker roles? I noticed those one of the services that made it over, and I think you can see how you can make one with using Service Plus and a VM that have that, that process on it.
Yeah, I really don't have any insights to share there. I know that worker roles are not really part of the Azure pack in this release, and that is our PaaS solution is Azure, and we have a lot of applications built on worker roles today. So. I really don't have any kind of crystal ball or insights into what's the roadmap for worker roles, and are we going to see those as part of the on-premise delivery? Or there is a lot of discussion going on about enabling PaaS for across cloud deployments and stuff, and I don't have an answer to where that's going to land.
When you showed the sort of the definition of the website cloud at the end there in the provider portal, there were additional roles in there aside from web worker roles. I saw a file.
Those roles were unique to the web PaaS, so they weren't actually Azure role types. So the worker role that you saw there was not the same thing as a worker role in Azure.
I was curious how the website interacted with those other roles. I saw a file service role, and I was curious what other role types are actually available.
So basically the web role is basically a stateless web hosting tier, so it doesn't store any application logic. And basically, the Windows Activation Service, which is part of IaaS, has been updated with what's called DWAS, which does dynamic activation. It's part of that. So it's a specially configured version of a web server that is stateless. There's a file server role where all of the web content is deployed for all the tenants. So that's basically, it can be on a NAS, it can be on a Windows Server device, but basically there's a shared storage for all of the web content. Then you'd also still have SQL Server if webs are using SQL Server, but the web files are all in the file share. You have a stateless set of web workers. They're called web workers, not to be confused with the worker role in Azure, which are the stateless IaaS nodes. And they will basically be in the two types of shared, where they're either in the kind of free shared tier, the premium shared, or in reserve mode. So there'll be workers allocated as reserved. As an operator, you can define how many instances of each role type that you deploy as part of your window or your web PaaS, as part of that web cloud. Then there's a load balancing and role or tier that is deployed, which is running ARR, application request routing, is running the ARR tier there for doing the load balancing and distributing load between the workers. It gets that, actually it's doing that by communicating with a database that is knowing the health of all the workers and will dynamically spray the request to the worker that can best accommodate the next request. There's no guarantee that request to request always goes to the same worker, unless the site's been configured to support affinity, so you can actually do some affinity binding. So at least requests from the same client will go to the same worker. They have that set. There's also a publishing role that gets deployed for basically where the FTP and web deploy endpoints can get published. They can be scaled out. And then there's also the source code control stuff that gets integrated. So there's a number of components. There's even a management tier where the REST resource provider is that integrates in to provide the REST APIs to the service. So there's a number of components that are part of that web PaaS. That's right. That's right. That's right. That's right.
That works even with the shared
Yes.
content?
And on the shared, it's actually still doing security envelopes between each tenant and using, and the reason these are dedicated, they have special filter drivers on the back end and throttling access to just their shares. And so there's kind of this security envelope for running each of the envelopes on the shared environments. Okay. Yes, another one.
An enterprise application, not designed for us, an old application,
Yes.
move it to the private cloud.
Yes.
Is that difficult?
Great question. So I'll repeat the question. For an enterprise application that's already been built, this is for a traditional, maybe a legacy, if I want to use legacy, or just maybe a production workload.
To make an example, many different Windows services, one website.
Yeah. But it's basically running on either dedicated machines or VMs, but basically a dedicated workload. How hard is it to move that to this environment? One, I would definitely encourage moving it into the virtualized space. So you can at least virtualize what you have today with very minimal changes. Make sure you define the networks appropriately for your application. Move it from being dedicated to virtualized. And at a bare minimum, you could have it running as even standalone. You don't even have to use virtual machine roles. You could just have VMs provisioned on the same network with the right connectivity to provide the system as is. Now, if you want it to be cloudy, which means scalable, so I want to be able to scale that application, that's going to depend on your application and whether it's designed to have multiple instances of itself and know how to behave. It may or may not be, and I don't have the answer to you. If your application is capable of supporting multiple instances of itself, then you could consider packaging that up and deploying it as part of a VM role so that it could be scaled elastically. But that'll really depend on the application. First step, though, would be make sure you virtualize it. That's right. Is it stateless enough? Is all the data stored in like a SQL Server database, or is it storing data to the local file system? You know, and even then, you might be able to have a common disk that you mount. So when you design your virtual machine tier, you can have a common data disk that is shared between the instances. You'll have to design that for your application. So there's some work that would have analysis that would have to happen to assess how applicable is that workload to the elastic virtualization tier. So I guess that analysis would tell you how hard it is. Okay. I can say as long as you guys want. So you're very welcome.